Hello and welcome to the 7th video of the sampling theory. And in the previous videos I have explained what is sampling and the problems based on that, and the tutorial I have explained. Now in this video I am going to explain what is the other test, that is students t distribution test, and also the problems based on that. These are all the one more type of test which we are conducting in order to test the hypothesis. So test of significance for the small sample, that is n less than or equal to 30. Now degrees of freedom. The number of degrees of freedom usually denoted by nu is the number of values in the set which may be assigned arbitrarily. It can be interpreted as the number of independent values generated by a sample of small size for estimating a population parameter. Students t distribution. This t distribution is used when sample size is less than or equal to 30 and the population standard deviation is not known to us. The t statistics is defined as modulus of t is equal to modulus of x bar minus mu divided by s into root of n. Here x bar is given by 1 by n into summation of xi is a simple mean, and s square is 1 upon n minus 1 into summation xi minus x bar the whole square is the sample variance, and nu is n minus 1, which denote the number of degrees of freedom of t, and mu is the population mean. So this is all about the students t distribution test. We also take a note of the value of t for given degrees of freedom from the table of standard values. If mod of t is greater than t of 0.05, the difference between x bar and mu is said to be significant at 5% level of significance. If mod of t is greater than t of 0.05, the difference between x bar and mu is said to be significant at 1% level of significance. If mod t is less than the table values at a certain level of significance, the data is said to be conformal / consistent with the hypothesis that mu is a mean of the population. Next comes the confidence limits for the population mean. The 95% confidence limits for mu is given by x bar plus or minus s divided by root n into t 0.05. For 99% confidence limits for mu, it's given by x bar plus or minus s divided by root n into t of 0.01, where the confidence limits are also called as fiducial limits. This is the table of the students t distribution level, and this column what I am referring here, this is the degrees of freedom, that is n minus 1 or n, it can be taken 1, 2, 3, 4, 5 like this, and these are all the confidence levels, that is 0.05 or 0.1%. Usually we will check with 1% and 5%. So with supposing if I want to refer 5 degrees of freedom at 5% level of significance, it will be 2.015, and similarly at 1% level of significance it is 3.365. So this are all, anyway it has been given. Whenever it is necessary we can refer to the table. Most of the time the tabular values will be given in the problem along with the problem itself. In case if they have not given, the table will be provided so that you can refer to the table and then get the values. First problem, find the students t for the following variable values in the sample of 8, that is -4, -2, -2, 0, 2, 2, 3, 3, taking the universe to be 0. T is equal to x bar minus mu divided by s into root of n. By data we have mu is equal to 0 and n is equal to 8. So x bar is given by 1 by n into summation xi, which is 1 by 8 into, let us add all these things, that is -4, -2 plus 0 plus 2 plus 2 plus 3 plus 3, which gives us 1 by 4, that is 0.25, that is the x bar. We have got it. Now let us substitute in the t formula. So before that, let's compute what is s square, that is 1 upon n minus 1 into xi minus x bar the whole square, which is 1 upon 7 into minus 4.25 whole square plus minus 2.25 whole square plus minus 2.25 whole square plus minus 0.25 whole square plus 1.75 whole square plus 1.75 whole square plus 2.75 whole square plus 2.75 whole square. So, which on simplification we get s square is 7.07 and which implies s is equal to 2.66. Now let us substitute in the value of t, formula of t, which gives us 0.25 minus 0 divided by 2.66 into root of 8. That is, t value is equal to 0.266. This is the value we are getting for the t. Next problem. A certain stimulus administered to each of the 12 patients resulted in the following change in blood pressure, that is 5, 2, 8, minus 1, 3, 0, 6, minus 2, 1, 5, 0, 4. Can it be calculated that the stimulus will be increase the blood pressure? So let x bar is equal to 1 by n into summation of xi, which is calculated as 1 by 12 into 5 plus 2 plus 8 minus 1 plus 3 plus 0 plus 6 minus 2 plus 1 plus 5 plus 0 plus 4, which gives us 2.5833. Now let's calculate the s square, which is 1 upon n minus 1 into summation xi minus x bar the whole square, which gives us, where n value is 12, so n minus 1 is 11, that is 1 by 11 into 104.9167, which is equal to 9.5379. How to calculate this s square already I have explained in the previous problem. Now, so s value is equal to 3.0883 and we have the formula for t is equal to x bar minus mu divided by s into root of n. Let us suppose that the stimulus administration is not accompanied with the increase in the blood pressure. So we take mu is equal to 0. So t is equal to 2.5833 minus 0 divided by 3.0883 into root of 12. That gives us 2.8979, which is greater than 2.201. So we conclude that the hypothesis is rejected at 5% level of significance. We can play with a 95%, we can say with a 95% confidence that the customer list in general is accompanied with the increasing blood pressure. Next, the third problem, weight of 10 people of a locality are known to be 70, 67, 62, 68, 61, 68, 70, 64, 64 and 66 kgs. It is reasonable to believe that average weight of the people of locality is greater than 64 kgs. Test for 5% level of significance where t 0.05 is given to be 2.26. But here they have given the t value and sometimes we need to refer to the table. Let us calculate the x bar in the usual way, that is 1 upon 10, because 10 values has been given, so n is equal to 10 and we will add all the values of the weights that is given by 2.5833. So when we take the s square, which gives us s square is equal to 10, that is 3. S is equal to 3.1623. Let us suppose that the average weight of the people of a locality is equal to 64 kgs, that is mu is equal to 64. Now we have the t value which is calculated as 66 minus 64 by 3.1623 into root of 10, which gives us 1.9999 and t is 1.9999, which is lesser than 2.26, hence we can accept. So the hypothesis is accepted at 5% level of significance. Therefore, it is reasonable to believe that average weight of the people of a locality is greater than 64 kgs. Thank you.